In lesson 3.3, we're going to look at solving systems of inequalities by graphing, and we'll look at it where there is two inequalities, and we'll review the shading rules and whether they're solid or dashed boundary line rules, and we'll do that here first. So, let's review those rules first. Boundary line rules, when you're graphing inequalities. No equal to part under the symbol. It's a dashed boundary line, meaning it doesn't include the points on the line. If you have the equal to part in, it's a solid. Here's our shading rules, reviewing these. If y is greater than or equal to, so the y side is bigger, we shade above. If the side with x is bigger, okay, or in other words, y is less than or equal to, we shade below the region. When you put more than one on a grid, the solution region is the overlap of the two shadings. And I'll show you a couple different ways you can do it and talk about a couple different ways. Really, that's the only region you should color in because that's the one that works for both inequalities. You could do a light, if you're using pencil, a light shading and a light shading and then darken in the overlap. That would work as well. So you want your inequalities in slope-intercept form. And if you notice on these first two, they are already solved for y, so they're in slope-intercept form. So let's write down some information to help us graph them. This one, okay, the y-intercept, because we're going to plot that first, is -3. My slope is 2, or 2 over 1. I'm going to use a solid boundary line for that one, because of the symbols, got the equal to part on it, and I'm going to shade above. So let's go ahead and graph that now before we look at the second one. Y-intercept is -3. Plot that on the y-axis. We're going to rise 2, run 1 for our slope. So from my -3, I'm going to rise 2, run 1, which puts me there. I'm going to do this a few times. Rise 2, run 1. Rise 2, run 1. If I went the other way, I'd go down 2, left 1, down 2, left 1. It's a solid boundary line, so let me grab my line here. And we're going to use a solid. So there's my solid boundary line. And I want to shade, oops, let's undo that. I want to shade above. So above that line would be up here. So let's see, that was a blue line. So let's shade that in blue. So I'm above this line. So right now we're talking about this region. Okay, but now we got to put the second one on there as well. And I will use red. Let's write down some information about this second one. The y-intercept is 2. The slope is -1 over 1. It's -1 here in front of x, but it's -1 over 1, which means down 1, right 1 from your y-intercept. It is a dashed boundary line, and we're going to shade below because it's away from y towards the side with x. We're going to shade below. So let's graph that one. Let me grab, well, let's plot the points here first. The y-intercept is 2, so we're right here. Down 1, right 1, -1 over 1, so down 1, right 1, down 1, right 1. We basically have these points on that boundary line. If I went the other way, up 1, left 1, up 1, left 1. That's a dashed line. Let's see if I have a red dashed. I'm going to have to do that one with green. I don't have a dashed, so to do a dashed, we're going to be like this. And I'm going to shade on this one, I'm going to shade below. So where is below that line? I'll go back to red here. I'm going to shade below. So I'm talking about this region right here. Now, what I want to do with the colors I used is I want to look where is it red and blue shaded, which would be this region. And I'm going to color that in green. So my solution region would be this region right here. That's where it's red and blue. Now, options you have, think about where you shade for the two lines and then just shade in that region. If you're using a pencil. You could do a light shading on the first one, a light shading on the second one, darken in then your solution region. Just some options that you have, but make sure I can see your solution region or your doubly shaded region or where your solution points are. And again, what does this mean? I'm not going to go through and show this. That means any point in that green area there, if I took the x and y values and plugged them in, they would work in both inequalities or make both inequalities true. Okay, solve these by graphing. Again, the solution region is the overlap of the two shadings. So let's look at these. Let's write down some information. These are already solved for y, both these. The first one, the y-intercept, is 1. The slope is -3/4, so down 3, right 4. It is a solid boundary line because of this symbol right here. That means solid, and y side is greater, so we're going to shade above. So let's go ahead and do that one. Y-intercept of 1. Down 3, right 2, so down 3, or I'm sorry, down 3, right 4. So we're going to be right here. Down 3, right 4. If I went down 3, right 4, it'd go off the grid. I'm going to go up 3, left 4, just to get another point on here. And if I did that again, it would go off the grid. So there's what I'm looking at, and that is a solid boundary line. So let me grab my line, and we're going to make this solid. Oops. Oops, I gotta undo that. Let me undo that. I just noticed I put one point in the wrong spot. This point is in the wrong spot here. Sorry about that. I'm gonna go up 3, left 4. So 1, 2, 3, 4. I would be right there instead. My line was a little off there. So let me grab the line again. It's a solid boundary line. I'm gonna extend it down. We're gonna shade above that one. So I'll shade this in blue. So I'm shading, and I'll just do it like that. I'm going to shade above. Now let's write the second one down. Let me do that in green. That is also going to be the y-intercept is going to be -2. The slope, I'm just going to use an M this time, is -3/4. So notice that slope is the same as the other one, so that should tell you something about the lines. Okay, and this one is also a solid, and we're going to shade below because it's away from y. So y-intercept -2, down 3, right 4, 1, 2, 3, 1, down 3, right 1, 2, 3, 4, right there. If we went up 3, left 1, 2, 3, 4. Be right there. Let me erase this little blue line, which shouldn't be there. So let's grab our line. This one is a solid line. Let's use red. So we're going to be right here, like this. And as you can see, and then we're going to shade below, so I'll shade that in red because my line is red. We're going to shade down here. These are parallel lines. Slopes are the same, parallel lines. There is no overlap here. Depending on where your shadings are, this could happen sometimes. No overlap, so this would be no solution because there's no overlap. You could give the empty set symbol. Now, if I would have shaded above my red line and below, so if the symbols would have been the other way and below the blue line, then the overlap would have been between the two parallel lines. So just because you have parallel lines doesn't mean it's a no solution. It depends on where the shadings are. So that can happen where it's in between them, the solution region. So just make sure you pay attention to the signs very carefully. Write and use a system of inequalities. This is a word problem. So if we read through this, medicine professionals recommend that patients have a cholesterol level below 200 milligrams per deciliter of blood and a triglyceride level below 150. Write and graph a system of inequalities that represents the range of cholesterol levels and triglyceride levels for patients. Let C be cholesterol, T represent triglyceride. Notice triglyceride is on the x-axis there, cholesterol on the y-axis. Now we only have first quadrant here because we can't have negative levels here. Okay, so really that's why we're just graphing in the first quadrant, another real life situation or model here. So we want cholesterol, so C, to be less than 200. We're not going to have the other variable on the other side, which is basically going to be, because cholesterol is on the vertical axis, is going to be a horizontal line. We'll do that, but let's write the other one. And we want triglyceride, so T, to be less than 150. Now, because cholesterol right here is on the vertical, that's like the y, so this is y and 200, so this is a horizontal. So you don't use slope-intercept method, this would just be a horizontal line. This one, because T's on the horizontal axis, is going to be a vertical line. They're both going to be dashed. Okay, so let's graph the first one. C is less than 200. We want a dashed line at 200. So let me pull up the dashed line here. So, and we want to do below that. So let me just say below that obviously would be this region. T, notice T is triglyceride, that's on the horizontal axis, so that's like X and 150, so that's a vertical line. So we're going to make a dash line for that also. Let me grab a different color. So at 150, we're going to do this. Now, you can't go above and below a vertical line, but where does T get less than 150? Well, here's 150. Less than's got to be that way, so we're going to shade on that side. So let's do that in green because I made my line green. So we're right here. Now, where's the solution region? I'm going to make it blue. Where both of these are true. Where both of these are true. Well, that would be where I have shaded red or green and black. So basically, it's over up to each of the dashed lines. Okay, which means any of those levels would fit both of them. So that's an example with horizontal and vertical. All right, find the vertices of a polygonal region. This kind of leads into what you're going to see in the next lesson with linear programming. But I have three inequalities. So we're going to do the same thing. Notice these we have to solve for y. So you need to solve for y on all of these. Get them in slope-intercept form. So this one, I'm going to subtract 2x. That's gone, so I have negative y is greater than or equal to negative 2x minus 1. Now I have negative y, that's like negative 1 times y, so I want to divide by negative 1 all terms. Remember, when you divide by a negative, reverse the symbol, so put that in your notes. Negative divided by a negative would equal a positive there, 2, in front of the x, and a negative divided by a negative, it's 1 divided by 1 is 1. So here's the first one, solve for y. So let's write some things down. The y-intercept, and I'm just going to use a b this time. The y-intercept is 1. The slope is 2, or 2 over 1. I'm going to use a solid boundary. And it's away from y, or the side with x is bigger, so I'm going to shade below. So if we graph that, y-intercept is 1. Slope is 2, or 2 over 1, so rise 2, run 1, rise 2, run 1. Be like that. I'd go down 2, left 1 to go the other way. And then we're going to draw our line, solid. So let me grab the line. I'll make it blue. So we're like that. And we're going to shade below. So below that line, because the line's blue, just realize we're over here right now. Okay, let's do the second one. Let's do black. Here, if I'm going to solve this one for y, I subtract x. So y, positive y, we don't have to divide to make this, it's going to already be solved for y here. So negative x plus 4. So there is that one. So just one step to solve that. The y-intercept is 4. The slope is negative 1, because that's what's in front of x, but as a fraction it's negative 1 over 1, which is going to mean down 1, right 1. We are going, that would also be solid because of the symbol. It's got the equal to part on it, and we are going to shade below on this one also. So let's graph that one. Y-intercept is 4. Down 1, right 1 would put us right on that red point. Down 1, right 1, down 1, right 1. And we're going to draw a solid line. So let me grab a line here. Let's do this one in red. Right there. And let's shade that in red. We're going to shade below. So that would be everything down here. So we're below and below. So if I just had those two, it would be kind of in that region right now that's red and blue. But I'm looking at all three, and then we're going to write down the vertices. It's going to enclose a figure here, and you'll see that after we do the third one. So let's go to the third one. Let's solve for y. So I'm going to subtract x. So 4y is greater than or equal to negative x plus 4. We're going to divide by 4. Okay, I divide by a positive, so I keep the sign that way. This would be negative 1/4 x. Okay, because that's like negative 1 there. And then 4 divided by 4, both positive, is that. So there's that one solved for y. The y-intercept is 1. My slope, negative 1 over 4, so down 1, right 4. Solid boundary line, so all of these are solid. And we are going to shade above on this one because the y is bigger. So we're going to shade above. So let's go through and graph that. My y-intercept is 1, same y-intercept as my blue line there. Down 1, right 4, which actually puts me right there where that red line crossed the y-axis, or the x-axis, excuse me. Down 1, right 4 would go off. Let me go the other way. Let's go up 1, left 4. So that would be right there. And let's draw the line. It's solid again. So let me I'll grab my purple line. And we're going to be just like this. And we're going to shade above. Let me do this one in, I'll do it in black, and then we'll figure out the region. So this would be black. We're going to shade above, which would be this, above that line. So if you notice, and I'll try and draw this in green, we've enclosed the figure here. Where is everything shaded? Inside this right here. We've formed a triangle. So there's my solution for all three of these. So we've formed a triangle, so that's the shape. And we want the vertices, which means the corners. Vertices means the corners of the figure. So where are the corners? It doesn't matter what order you list these in, and this is going to lead us into linear programming and finding maxes and mins. Let's go with this point first, right here, which is the coordinate 0, 1. So there's one vertice. Let's do the other one that's on the x-axis here. That would be 4, 0. And let's do this point, which is 1, 3. So if they said list the coordinates of the vertices, it would be those three, and we have formed a triangle. Now sometimes when you have 4, you're going to form some type of quadrilateral, and I did assign a few of those, and that's the lesson.